This video is on the addition of carbenes to double bonds. Carbenes are carbons with only 2 bonds and a lone pair of electrons. They are very reactive and very unstable. Why? Because carbon wants 4 bonds, not 2. The carbene has both a lone pair and an empty p orbital. Therefore, it can act as both a nucleophile and an electrophile. The alkene will attack the empty p orbital, and the lone pair on the carbene will attack the carbocation formed in this process. So in other words, the carbenes are the best way to add a single carbon unit to a double bond to form a cyclopropane derivative. As the electrophile and the nucleophile are the same atom, you will always get addition onto one single face, making this reaction very stereospecific. So how does one make these carbenes? Well, there are 3 different ways. The first method is using diazomethane, a chemical that looks like this, which can resonate to form this compound where the carbon has a negative charge and an extremely good leaving group in the form of nitrogen gas. Of course, add a little bit of heat or a little bit of a catalyst such as copper, and the nitrogen will leave to give you your carbene. You would make this in situ, and once you form the carbene, there's no going back. It will react with a double bond. So if you see conditions like this alkene with diazomethane and copper cations, you know you will be forming a cyclopropane product. The second method is the elimination of protons and a leaving group from a single carbon. So for example, if we happen to have chloroform and add a strong base to it, we can deprotonate to form this trichlorinated carb anion. If we are then able to make a chloride leave also, we will form a dichlorinated carbene. This is referred to as an alpha elimination, and it can only be done, in this case, with chloroform or with bromoform in the presence of a strong base. This is also a reason why you should never dump strong bases or, say, sodium hydroxide solutions into the organic waste, because you never know what kind of mixtures you can create. Anyway, if you see a dichlorinated cyclopropane derivative, then odds are you used chloroform and strong base. So for example, in this case, if we take cyclohexene, the presence of chloroform and sodium hydroxide, what do you expect the product to be? You may pause now. And yes, you would be correct. It would be the cyclopropane derivative with the 2 chlorides on the apex carbon. What about this one? Bromoform with tert-butoxide and tert-butanol. You may pause now. And here is the answer. The third reaction is one you need to know by name. It is the Simmons-Smith reaction. Here we'll take an alkene with diazomethane in the presence of zinc and caloric amounts of copper, and you will form your cyclopropane. Now, this is not technically a carbene reaction, but a carbonoid reaction. A carbonoid is a carbon that is stabilized by a metal, in this case, zinc. Now, unless you go on into graduate school to do chemistry, this probably does not impact you at all. It's just a carbene reaction. It's just we can isolate this species that forms when zinc reacts with diazomethane. However, the end results are the same as if we formed a carbene. Alright, so if that is the case, what would you expect the product of this reaction to be? Well, you are correct. You would make this cyclopropane derivative. Now you have a go. What would the product of this reaction be? You may pause now. And here's the answer.